You ever notice how some things in life seem to change in this perfectly predictable way? From your savings account to the rungs on a ladder, there are these hidden patterns all around us. Well, today we're going to pull back the curtain on the simple math behind these patterns. And believe me, it's a tool that can literally help you predict the future. Now, really, think about it for a second. What if you could know with total certainty exactly what your salary would be in 10, 15, or even 25 years? I know, it sounds like some kind of superpower, right? But it's really just about spotting the right kind of pattern. So, let's meet Reena. She lands a job with a starting salary of 8,000 rupees and gets a guaranteed raise of 500 rupees every single year. You can see it right there. Her salary just ticks up. 8,000, 8,500, 9,000, and on and on. That steady, constant increase, that's the pattern we are hunting for. And here's the cool part. This kind of predictable, step-by-step pattern isn't just for salaries. Once you know what to look for, you start seeing it absolutely everywhere. So this pattern actually has a fancy name, an arithmetic progression, or just AP for short. But all it really means is it's a list of numbers where you take the exact same step every single time. And that fixed step, we call that the common difference. It can be positive, negative, or even zero. See, every single one of these patterns boils down to just two key ingredients. First, you've got the starting point, which we call A. For Reena, that's her first salary, 8,000. And then you have that fixed step, the common difference, which we call D. For her, that's the 500 rupee raise. With just A and D, you can build the entire thing. And once you start looking, you see them everywhere. The rungs of a ladder getting shorter by a fixed 2 centimeters. Savings for your kid growing by a steady 50 rupees each year. Even the simple interest on a loan, which piles on the exact same amount year after year, all of them are following the exact same rules. Okay, so spotting the pattern is one thing, but using it to, actually predict the future without writing out a giant list, for that, we need a shortcut. We need a tool. We need the prediction formula. Let's just break it down with some good old-fashioned logic. To get Reena's salary in year 2, we add that 500 rupee raise one time. For year 3, we add it twice. For year 4, you guessed it, we'd add it 3 times. You seen the pattern here? For whatever year we're interested in, let's call it N, we just add the raise N minus 1 times. It's that simple. And that simple logic gives us this. This elegant little formula right here, that's our crystal ball. It just says that any term in the sequence, which we call AN, is just the starting term A, plus that common difference D, multiplied by N minus 1. This lets us jump to any point in the future instantly. All right, so let's put it to the test. What about Reena's salary in her 25th year? We just plug in the numbers. A is 8,000, D is 500, and N is 25. The formula does its magic and gives us 20,000 rupees. We didn't have to add 524 times. The formula got us there in one shot. Powerful, right? Okay, awesome. We can jump to any point in the future. But what if we need to know the total of everything added up along the way? Like, what were Reena's total earnings over all 25 years? Now that is a different challenge, and it's going to require another seriously clever trick. Let's take Shaquila's savings box, for example. She starts with 100, then 150, then 200, and so on. To find the grand total after 21 years, we'd have to sit there and add up 21 different numbers. I mean, you could do it, but who's got time for that? There's got to be a smarter way. And guess what? There is. The story goes that a young student who would grow up to be the legendary mathematician Carl Friedrich Gauss was given this exact problem by his teacher. To keep him busy. Find the sum of all the numbers from 1 to 100. The teacher probably thought, that'll keep him quiet for a while. But Gauss, he was on another level. Check out what he did. It's pure genius. He wrote the list of numbers, and then right below it, he wrote the list again, but backwards. Then he added them up. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is, you guessed it, 101. Every single pair adds up to 101. So you've got 100 pairs, and every single one adds up to 101. That's 100 times 101. But remember, he used the list twice, so he just had to cut that number in half, and boom, 50-50. The legend says he solved it in just a few seconds. Now, here's the best part. That amazing trick from Gauss? It gives us a universal formula for finding the sum of any arithmetic progression. I know it looks a little complicated, but it's really just doing the same brilliant pairing logic. S is our sum, N is how many terms we have, A is our start, and D is our step. So let's use this thing. For Shaquila's savings, we've got 21 years, so 21 terms, a starting amount of 100 rupees, and a step of 50. You just pop those numbers into the formula, and bam! The total amount in that money box after 21 years is 12,600 rupees. No calculator mashing required. So now, we've got these two incredible tools in our toolkit. One for finding any term, and one for finding the sum of all the terms. We basically have a new superpower for cracking all kinds of real-world problems. Just look at all the different problems we can tackle now. A flower bed with rows of roses decreasing by 2 each time? We can find out how many rows there are. A TV factory with production numbers going up steadily? We can actually work backwards to find out what their first year of production was. A loan being paid down by a fixed amount? We can find the total paid. They all look different, but underneath, they're all the same simple pattern. Let's zoom in on that TV factory for a sec. All we knew was that they made 600 sets in year 3 and 700 in year 7. Because that growth is steady, it's an AP, we can figure out that the common difference must be 25 sets per year. And from there, we can work backwards and see they must have started by making 550 sets back in year 1. It's a straight line. It's perfectly, beautifully predictable. So what's the big takeaway from all this? This isn't just some boring math homework. It's the language of steady, predictable growth. And it doesn't matter if it's money or manufacturing or even patterns in nature. The moment you spot that steady, constant change, you basically hold the keys to the kingdom. You can predict the future, and you can neatly sum up the past. And that really brings it all back to you. Think about your own life for a minute. Your savings plan, maybe your fitness routine, the number of pages you read in a book each day. Where do you see this steady, predictable pattern? Because now you have the tools to actually calculate it. So what are you going to go figure out?